I set up a hydrogenation reaction to reduce a nitro group to the corresponding amine. To begin, I needed to find suitable reaction conditions, so I consulted the chemist's cookbook, heading straight to the miscellaneous section to look for examples of nitro group reductions. I found a protocol where a nitrobenzene was reduced using Rani nickel under a hydrogen atmosphere. Other examples involve metals like iron or zinc. Ultimately, I decided to try these conditions using palladium on carbon. I set up a 2-neck round bottom flask equipped with a magnetic stir bar. Into the flask, I added nitrobenzene dissolved in ethyl acetate under a nitrogen atmosphere and began stirring. Next, I added all the palladium on carbon at once, followed by acetic acid. I then replaced the nitrogen balloon with a hydrogen balloon and attached a vacuum line to the second neck. After securing both connections with clamps, I turned on the vacuum pump. I evacuated the nitrogen from the flask by opening the vacuum valve, then repressurized it with hydrogen. I repeated this cycle 3 more times to ensure an atmosphere of hydrogen. The reaction mixture was stirred for 1 hour at room temperature. Once the reaction was complete, as monitored by TLC, I removed the hydrogen balloon and filtered the mixture through a short path of sealyte, washing it with additional solvent. It is important to note here that palladium on carbon is pyrophoric and can ignite spontaneously in air. It is important to work with it under an atmosphere of argon or nitrogen, try not to let it dry after working up the reaction, and dispose it immediately into a container for palladium waste. After filtration, I transfer the solution into a round bottom flask and remove the solvent under vacuum. The resulting crude product was then purified by flash column chromatography.